There's DG. Hi, DG.
Okay, real quick before we get this kicked off. The closing ceremonies are after this talk in this room, and then the after parties at Null Space Labs are later tonight. We hope you can all make it. I think that's it. Is that it? Last call for t-shirts. Literally last call. Sprint out right now. All right. Closing out LayerOne 2023 is my good friend Machinist with, hold on, it's going to take a second. My laptop dreams of polydactyl sheep, deep learning image generation for fun and profit.
Okay, and we're back. Okay, nice to see all you guys. I recognize a couple of faces, a lot of unfamiliar faces here, so thanks for showing up. Hope you guys had a fun LayerOne so far. So my talk here is about AI image generation. I've been playing around with some stable diffusion here for the last number of months, and boy, is it interesting. Is there a lot of stuff here, and I think it's so interesting I wanted to come here and share it with all of y'all. So, who am I? Well, my name's Machinist. I've been around these hacker spaces for well over a decade at this point, and I keep coming back for some reason. Little word of warning, I am not a specialist in this area. There's a lot of high-end mathematical jargon that, while I understand the words in the sentences, I don't necessarily understand them in all this order. What I do have a deep background in is black box testing, and that's mostly the angle that I'm coming at this talk from, is someone who doesn't really have an understanding of how this stuff is built. I'm mostly looking for what it does with my inputs. So stable diffusion, this big complex mess of natural language processing, running it through a latent space model database, running reverse Gaussian noise diffusion to pull an image out of sheer nothingness and a text prompt. Kind of interesting stuff. I'm sure some of you guys here in this room could elucidate me to some more of the details, but that's pretty much the gist of it. Stable diffusion is running here locally on this machine. It's basically a Python install with a number of packages. It's not even a high-end machine at that point. It was like a $2,000 laptop 2 years ago, so pretty much everyday commodity hardware can run this well enough, while there is still a little bit to be desired for generating the large-scale models, which requires much more GPU horsepower than I have at the moment. So basically, same thing I've been babbling about. 8 gigabytes of VRAM is about the bare minimum you can run on a local machine and have this stuff still work. Okay, so what kinds of things can we do here in stable diffusion? The most interesting thing I think it does is text-to-image processing. So I give the GUI a small prompt with modifiers and flags and a little bit of number crunching, and it outputs a bunch of images. We can also get it to work on images already contained in the environment, looping back over and over iteratively. It can take a low quality image and turn it into a higher quality image, and that leads us to the tremendous upscaling ability. Stable diffusion by default was trained on a database of 512 by 512 images, so that tends to be its native output, although the newer version, Stable Diffusion 2.0, is natively outputting in 768 pixels. Not really a big deal because we have upscaling that works real good. Outpainting is interesting because you can take an image and give it a description of what should be filling in the blanks beyond the space of the image itself, and with a little bit of prodding, the system can go ahead and populate all of that. In painting is something that I didn't do any testing on, but basically you take an image, you mask off a little area, and you can tell the program to fill in that new area with whatever you're describing. So basically, when we're working with a system, we give it a text prompt that is essentially the subject you want to see, the setting you want to see, and any modifiers. What this does exceptionally well is style transfer. So if you want to see a famous person's art in another famous person's style, the database has enough references between both of those text prompts that it can kind of stick them together and mash it all up. There's also negative prompting that you can use to, let's say it generated this anime image, but it has a few too many tentacles for your taste. You can negatively prompt that out and have the software dispel all this stuff. Lots of technical numbers and sliders controlling details. We'll be sure to point out the ones that are interesting, basically like how much leeway do we give the system to invent stuff versus how true to my prompt we want everything to generate. The underlying model of stable diffusion is the LayerOne 5B model. I guess it was trained on 5 billion public domain images, giving an image and text clip. Took all of that and set it in a lower dimensional latent space, which saves on disk space and allows us to reference that model on this computer while generating the images, and pulls all that out of the latent space and noise generation. Several other models have been popularized on the internet for various uses. Waifu diffusion is a fun one, trained on a whole bunch of anime. We'll touch on that. Okay, so how about some live demos? That's what we're here looking for. So maybe we'll do this like Whose Line style. Let me get my system booted up. And it's here. Okay, so the automatic 111 GUI runs as a web browser. You can even have it broadcast out to the internet in large. I often set this computer up for other people to use on our Discord channel, etc. So how about somebody give me a subject? Someone yell something out. An image setting, come on. A tank? Where is this tank?
Ball pit.
In a ball pit? A Sherman tank in a ball pit. And give me an artist.
Dolly.
Okay, so let's hit the go button, see what happens. This takes a number of minutes, but like I said, sort of limited GPU power. What I find is tremendously impressive about this system is it wasn't that long ago that you could only do this in a cloud-based way, referencing someone's servers who knows where, and the results were generally some sort of amalgamation of dog slugs on a psychedelic afternoon. And the way I have this set up right now is we're making 4 batches of 4 images each. We're sort of giving ourselves a statistically significant sample size because honestly, most of what this is going to generate is going to be garbage. A lot of weird, distorted, extra-fingered images. And it's our job as the sentient human to filter through things and say, okay, here's some quality, here's something I want to work on. To be honest, I think about 1 out of every 100 images is something that is worthy of work. The rest of it's just noise. We'll look through some of that, but the anticipation is killing me. It's almost done. The newer versions of Stable Diffusion run a little bit faster because I guess whatever is updating this status bar on the GUI is consuming like 10% of the total system RAM. A Tank in a Ball Pit by Salvador Dali. Yeah, you have to be specific, right? That's not bad. That's some Limp Watches style. Definitely Dali-esque. So we can see that it got the hint, but we need to do some modification. We need to sort of guide the system a little bit, and that's what we would do with negative prompts. So rarely do you get the first result to where you want it to be. You have to sort of massage the prompt. And I find that for every statement in the prompt, it sort of changes like the order of importance from highest to lowest, generally separated by a comma. You're trying to figure out how to input data to this natural language processing system without having a whole lot of feedback other than what you get at the end, the final image. So, kind of interesting. We got close, but I think we'd have to poke at this to get something a little more along the lines of what we're looking for. Now, there are a number of services online that do very similar things. Midjourney is the first one that comes to mind with its own Discord server. You just type a prompt and it outputs one result. And I'm pretty certain that Midjourney is running Stable Diffusion under the hood with their own custom models. And there's got to be some kind of mechanical Turk in there that is like filtering out the noise from the good stuff, because you generally see really high quality outputs from Midjourney. But again, it's not living on your hardware. Just for reference, we are running in airplane mode right now. So no Wi-Fi. We're disconnected from everything. This is all being generated locally. Take a look back. These are a couple of choice results that came out of quite a bit of crunching. The big scary dog is what I imagine my Labrador looked like to the FedEx guy on Christmas Eve. Holy shit. Junji Ito was the artist here. He's a famous horror manga artist, and there's one that comes to mind of like his experience owning cats, and this is a very similar picture from a cat biting the shit out of his hand. It took a while to get those results. On the right over here, we've got a hexapod Mars rover cruising around taking a selfie. And if we look through some of our results, we can see sort of the process that we used to get there. So, as I mentioned, you're going to filter through tons and tons of weird results, stuff that's not quite right. And with a little bit of tuning of the prompts and enough trial and error, you finally find something. Oh, this is a good one. Finally find something workable. Not quite that. Yeah, some extra jaw action. Yeah, so maybe out of about 200 tries, I got a handful, 3 or 4 that were worth any further processing. You'll notice that there's a large text description on the output here, and it actually cuts off the result of, it cuts off the entire text input because of the length of the file name, but there are ways we can recover that information out of the original PNG. Why I mention this is it's useful for recreating the constructions. So we'll go ahead and make a copy, and we'll look at it through Stable Diffusion. Okay, we got my copy. So not only do we have the entirety of the positive prompt, we've got the negative prompt and all of the details we use to generate that. So with all of these details, we can go ahead and try and recreate the scene from nothing. Let's give that a shot. So how many sampling steps is useful? How much do you need this machine to crunch numbers before it outputs something that doesn't look like noise? About 25 to 30 steps tends to be enough. Anything beyond that, it doesn't really get you any extra coherence on the image. What it tends to do is start to drift away from the original intent and turn to something unanticipated, unpleasant. It's hard to describe anything other than like an emotional stance of how some of this stuff outputs. Okay, a bunch of different sampling methods, just different algorithms you can use to generate the image. Most of these samplers will converge on a similar image, so it doesn't really matter which one you use. Some of them run a little faster than others, but this is all running in significant time for us to do a live demo up here, so just give you an idea. The CFG scale, this is also an important slider, is how strict to the prompt do you have the computer generate the results? So I like to run about 11 or 12, somewhat strict. Anything less than 10, it gives the computer a lot of freedom, all the way up to 30 where it gives the computer no freedom, and that's where you start to have weird results. I've been holding Stable Diffusion user group meetings at Nullspace recently, and people have taught me some interesting tricks, like you can run the scale backwards and it produces images completely opposite of what you're trying to prompt. Really interesting things can result from tremendous use of the negative prompting method right here. So we got 50 sampling steps. We got the Euler sampling method, number positive 10 on the CFG scale, and we'll want this seed to regenerate the original result. -1 is a randomized seed. Okay. Now let's see if we can get close to the big scary barking dog dripping and spitting saliva with crazy eyes. All right, while that's processing, so image to image. Once I produced an image, I was interested in seeing what the system would do to modify it, where it would take things. The prompt here I was using was an undersea creature by Dale Chihuly. He's a famous glass artisan, makes these really weird tentacly things that hang up in museums and foyers or whatever. And while the machine was working through this image, iterating over itself, it came up with some interesting changes. It didn't depart from the original intent, but rather modify it. So this is the result of the machine iterating over the same image, and it becomes less of like an art display and more focused on the undersea life as you see things start to morph and change behind the scenes. It's just kind of interesting to see the way it would fold in on itself, start to pull out the details that were significant and get rid of the details that it wasn't so concerned with, that I wasn't so concerned with. Upscaling. So I mentioned that the native output resolution of these images is 512 by 512, but you can upscale this as much as you want. There is a square computing penalty that you get every time that you try and upscale the image. Once you get up to 4K or 8K images, it takes a good 10 or 20 minutes to process each image because the system is actually dealing with 512 by 512 chunks as it's upscaling everything based on your text prompt. I find that's also another instance that it's useful to output multiple iterations of the same image, because once you start upscaling, it starts looking at smaller segments of the entire frame, and it might start inputting artifacts related to your prompt, but not exactly what you want. Starts duplicating things. I'll show you some images, some examples of that here in a second. Okay, so did we prompt this correctly? Something went wrong. That's okay. Sometimes things went wrong, but it got close. Not that one. Okay, that's kind of weird. Sure, I'm missing something, but we'll come back to that. So some sample upscaling. This image starts at 512 by 512. And you want to run any one of a number of upscale algorithms. So outpainting, this is another interesting detail. You give the system a description of the scene you want to see, and with some luck, it will fill in the blanks. You can definitely see there's like a pretty strong boundary of where the image started, and sometimes it will fill in like a distorted watermark. That's something kind of common from this system that you'll see, and that's something that you would typically want to use in your negative prompt away any sort of watermarked images, and that sort of filters that stuff out. Another interesting artifact I've seen is, while this system is not supposed to handle text, it will process and output text. Lots of it is gibberish, but often it is quite relevant to the image. So I'm sure we've seen a bunch of these solar system tour posters from various sources. And it knows Mars is there. It knows old is there. How is it processing our language from the lower dimensional latent database that it's pulling this information from? It boggles my mind. Like uncanny valley, creepy, like I just had a stroke. I see all these letters, but they don't make sense. So we've accomplished a little bit of a little bit of upscaling, and we can see that there's some new artifacts that start to appear. Some distortion to the eye is the one that's jumping out at me. When I did this previously, it created like a weird ink spot here. But just to show you an example of why it's important to do multiple iterations to have a statistically significant sample size to pull from, because at the end of the day, the system doesn't have any idea of if it's outputting good information or not. It's up to you, the sentient human, to decide that. So definitely some horror shows to find in here. I have certainly noticed that while working on trying to dial in on a subject, sometimes you push the system a little too far. That's certainly what happened with the realistic rat fink that we have up here. The number of eyes is certainly disturbing. Also, a photorealistic Homer Simpson got close, but for some reason the teeth are all wrong. Often you'll find distorted teeth, certainly distorted hands and fingers. That's something I'm sure we've all seen out there in the media. Not really a good way to fix that in this system. It has to do with the way the training was set up, not really focusing on limbs. So often you'll have missing digits, extra digits. It's a good way to spot this stuff out in the wild too. While this image generation tends to be pretty solid and convincing, every once in a while you can find a detail that's inhuman, unreal, something sort of breaking that boundary. Recently I finally saw my first deep fake commercial with Elon Musk trying to hawk some terrible Bitcoin derivative or whatever. And while my somewhat trained eye could pick that out, I could see how that could easily convince someone that this is the real thing. I think that's probably the most poignant talking point of this AI proliferation we've been seeing in the last year or so. We jumped some boundaries, and this stuff got really good really quick, and it's now in everybody's hands. What does that mean in our day-to-day life? It probably means that you can't trust anything you see anymore. It also makes things plausibly deniable. Oh no, that wasn't me in the swimming pool with a bunch of hookers. Like, that was totally stable diffusion. You can see there, that one's missing some fingers. So this stuff isn't unrecoverable horror. With regenerating the prompt and adding some variations, you can turn a horror show into something a little more cutesy, Mickey Mousey, guiding the system towards what you want. So it's not all a wash, it's not all out of control. There is some way to guide this with enough experience, with enough intent, knowing the system's limitations, knowing when to walk away from this stuff when you've gone down too far of a rabbit hole. And so, does anybody have any comments at the moment? Anybody have some thoughts, anecdotes? How about a show of hands? Who's using this kind of stuff these days? All right. Now, are you guys using this on your local machine? Okay, cool. So a couple of experienced users here. I'm sure we've all been down similar rabbit holes. You're raising your hand. You have something to say? The upscaling works on any photo you give it as long as it starts out as 512 by 512. What's that? Does the upscaling work with any image or only with the AI generated images? Was that your? Okay, yes, and it works with anything you can feed it. So you can take like an old pixelated video game sprite, and with enough poking and prodding, you can turn it into something HD and very reasonable. Doesn't come off automatically. It doesn't happen on the first try, but again, with a statistically significant sample size, we can do the thing. I still have a little bit of time, so we can play with this, see what it does. Conference room of tired hackers and a single trans-dimensional octopus. So while it's processing, let's look through some highlights here. Brain coral, arabesque, sand mandala, fractal, romanesco, broccoli, ferns, Fibonacci spirals. So there's details of this all embedded in there, mixed together, and kind of interesting to see the way with a little bit of poking and prodding you can change this, you can delete some colors, change some of the themes, and it goes on and on and on forever, ad absurdum. And I think we actually created an accidental datagram in here somewhere. We'll find him and pull him out. Oh, by the way, this is a preview of the NSL after party today. So in case you guys aren't hip to that, that's where we're going when this is all done. Please come by. There are details in just a moment. A lot of beard. And I think that was the one that we got DG out of the back, but it was in image to image. right here. You see a little secret DG poking out of the back? Conference room, transdimensional octopus, not so many hackers. So a little bit of guidance sort of gives you a perspective of the relevance of each one of these keywords and how you have to sort of change them around, ways you can emphasize and de-emphasize the prompts. So by putting phrases in between parentheses, you can emphasize the prompt. You can extra emphasize the prompt with either extra parentheses or by giving the prompt a value where 1 is a standard emphasis and anything less than 1 would de-emphasize. Okay, so a couple of fails, that's okay. Let's use the same prompt in the positive and negative prompt. So we want it to create a mandala, and then we want it to create things that are not a mandala. Honorable mention here is a Thomas Kincaid village on fire in the middle of a galactic empire war. Super Mario versus Garfield, complete with extra digits. Oh, and this was a stunner. Black hole as a Magic the Gathering card. Like, wow. Just about wrapping up here. Disney Princess Sea Creature illustrated by Ernst Haeckel, a very famous undersea life illustrator. Quite good. So while we're finishing up here, anybody have any last comments, questions? Any thoughts on where this is going forward? I'll be frank and say that playing around with this stuff has deeply changed my perception of what is computable and what is not. P still does not equal NP. They're probably different sets, but this certainly has taken a lot of the busy low-end work out of graphic design, the same way that computerizing machinery took a lot of the busy low-end work out of manufacturing 50 years ago. So I don't know how we ended up in this weird AI dystopia where computers are creating art and writing poetry and I still have to go to the office every day. But surely there's some use case here. It creates art. Not all art is beautiful, especially when you're a beginner artist like myself. I make no claims to be an artist, but boy, does this extend my hand significantly in ways that I never imagined before. Even just for plopping clip art in news articles or whatever, right? Like this is probably significantly used for that kind of stuff where it used to previously pose a terrible strain on the artist's wrists. Okay, so here are our results of what is a mandala and what is not a mandala. So in case those of you are unaware, mandalas are those very intricate sand designed sculptures that Buddhist monks will make over days and days and days, very geometric and radially repeating, and the moment they're done, they wipe it all away to signify the impermanence of being. I think they're kind of magical that way, but it's interesting to see the way that this pulls up like landscape art and cross sections of rocks and all sorts of weird, interesting stuff that's buried in here just waiting for us to pull it out and discover what this stuff is useful. So wrapping up here on some thoughts of where this AI is going, like there's a great quote by Frank Zappa. He says, a computer can tell you a great emotional story, but what it's missing is the eyebrows. All right, one last slide just in case those of you are unaware. Null Space Labs after party 2 blocks away from the Burbank Airport. We're all heading there now, be there now. So thank you all, you've been great. Thanks for coming to LayerOne.